All right, hello, Algebra 1. We are here today going to do the remote learning number 2 assignment. And before we do that, I kind of have to show you something that we never really got to do. And you've probably seen it before in Algebra 1, but you might forget it. Or you might not know why we do it in the first place. But one of the things that you're supposed to do is that assignment, this question right here, complete the square part 1 of method. And then we have to do some more completing the square right here. And I didn't want to make you do that until I was sure you knew how to complete the square. So we're going to go through and do a short little mini lesson on completing the square and what it means, why we do it. So sometimes we're given something like this where we're like, I don't really know how to factor that. How am I going to find the solutions if I can't really factor it? Hey, Sammy, will you close the door, please? Okay, so anyway, let's go to like a simpler example, something like this, where we definitely could factor this, and we could easily find two numbers that multiply together to get negative 15 and add together to get 2. We could probably do that pretty fast, and we wouldn't have to complete the square. This would all be kind of too much work. But it's easier for me to show you why we complete the square with smaller numbers, not numbers like that. Okay, so let's say we have this little polynomial here, and then I ask you to solve this quadratic. And by that I mean, where does this parabola cross the x-axis, right? That's what we're looking for. We're looking for two numbers that are x-intercepts. All right, now the first thing we want to do is we want to add 15 to both sides. So you can see I did that here, plus 15, and that's how I get this next thing of x squared plus 2x equals 15. And now I'm going to go ahead and color these things as x squared, 2x, and 15. And you can see I kind of have like a geometric representation of those values. And the box here, the area of this box of side length x and side length x, so the area of the square is x squared, right? The area of a square is side times side, or side squared. In this case, the side length is x, so the area of this is x squared. There's a rectangle right here where we can see x is still the same length. See, like x still has the same value. And instead of having another side length of x here, this side length is 2. So the area of this rectangle is x times 2, or 2x. Hey, Sammy, I really need you to close the door. Go potty downstairs. Go potty downstairs. Okay, so the area of this rectangle is 2x. And then I just can make this random square here whose area I really want to be 15, but it doesn't matter what the side lengths are yet. Okay, so the main thing is the area of this square plus the area of this square must be the area of this square, which is 15. And our job is to figure out what's x have to be if that's true. So the idea of splitting this middle term and completing this square, and I'm sure maybe you've heard that before, we kind of divide it by 2, right? That comes from this concept. I'm going to divide this rectangle down the middle so that now I have two rectangles that are x by 1, right? The area of this is x times 1, or x. The area of this is x times 1, or x. So the addition of those two, the sum of those areas is 2x. So this area, the area of this rectangle is still 2x. Now I'm going to split these up and put them on this square to make them, adjacent. So still the side length of this rectangle, is still x. Right? See how they match up like that? And the side length here is 1. I'm going to put another one. I have to erase this now. I'm going to put another one right here. So that the side length here is still x and the side length here is 1. Well, if that's true, then what is this little extra spot right here? This little spot completes our square, right? Because now my square here has a side length of x plus 1, And my square here has a side length of x plus 1. So this is a square as long as I fill in this little space. Well, what's the area of this little space? 1 times 1. So the area of this little square is 1. All right, well now we're pretty much there, because now I see that a square with a side length of x plus 1 has the same area as my square of 15. Oh, well, I missed one crucial step. All right, according to the laws of algebra, are we allowed to add something on to the left side of an equation without adding it on to the right? No, I'm not. I'm not allowed to do that, right? If I add 1 in here, I can't just make it up. I have to add the same 1 over here somewhere, right? Here's another square with the area of 1. But this looks kind of silly. They don't really match up very well. So let's just kind of fill in maybe this space here instead. And we'll say that this area of this rectangle has an area of 1. And now the area of the whole thing is what? 15 plus 1, or 16. So see, we just added on the area part, not the exact little shape, but how much area that little shape had. So now the square here has an area of x plus 1 squared, right? That's the area of this, because the side length is x plus 1, has the same area as this square of 16. I'm also saying that if this square is 16, what does this side have to be? Well, what times what is 16? 4. Right? 4 times 4 is 16. These side lengths have to be 4. Well, then x plus 1, this side length, has to be the same as this side length, so x plus 1 must equal 4. All right, and if that's true, then I can subtract 1 on both sides, and x winds up being 3. But what other two numbers multiply together to get 16? Negative 4. So I know this is a strange concept and super abstract, but what if the sides were negative 4? I know we don't usually or ever say that a side length is negative. Side lengths are always positive, but let's pretend like it is. Then we could say x plus 1, or this side, must equal this side, which is negative 4. Now if I subtract 1 on both sides, I get that x equals negative 5. And these are my two solutions. We would have gotten the same thing if we factored this, right? Because in factored form, we would have gotten x minus 3 times x plus 5 equals 0. Would have wound up looking like this. And then we would have set both of these things equal to 0 and solved and gotten 3 and negative 5. So this is just the idea of completing the square. And in a much more efficient process, what we are told to do is take the middle term and divide it by 2. Well, I'll just write it here. Take b, this is b, right? And I divide it by 2, and then I square it. Okay? So in, let's say, standard form, ax squared plus bx plus c. Yes? So b divided by 2 and then squared gives me a number. And I take this number and I add it on right here. So what is b? It's 2. What's 2 divided by 2? 1. What's 1 squared? 1. But I can't just add 1 to the left side without changing the entire equation, right? So I have to add 1 to both sides. And now we can see it visually. X squared plus 2x, x squared plus 2x plus 1 equals 16. And then I could see that this in factored form is x plus 1 squared equals 16. And then I have to take the square root of both sides. And then I see that x plus 1 equals positive or negative 16. Oh, positive or negative 4. The square root of 16. And then I continue with what I did last time, where we have x plus 1 equals negative 4 and x plus 1 equals positive 4, and we solve that going forward. Okay, so with that in mind, we could do something that's a little bit harder like this. And there's a question in there that's like this, so maybe I'll just wait. But let's move forward with the first question. The rest of these will go by kind of fast. Okay, so determine the y-intercept of the following equation. Okay, and what we need to do, first of all, a y-intercept, right? A y-intercept needs to be on the y-axis, right? On the y-axis somewhere. Okay, a y-intercept needs to be on the y-axis, which means the x value of the y-intercept must be 0. Yes, so we look over at this, and I already see a bunch that don't have an x value of 0. There's 3 actually. So that means that those cannot be our answers. Also, I see that this is a quadratic, and because of that, we'll probably have 2 solutions. So it'll probably be this one. But what we really want to do is just set these let's FOIL this. Let's expand our binomial. Negative x minus 3. Okay, so I'm going to do x times negative x is negative x squared. X times negative 3. Negative 4 times negative x. And negative 4 times negative 3. So then I have negative x squared plus x plus 12. All right, and the intercept, the y-intercept, comes from where x equals 0. So I'm going to plug in 0 for x, right? So that's negative 0 squared, or just 0. 0 plus 0 plus 12 equals y. So y must be 12 when x equals 0. Cool. So this parabola crosses up here somewhere at 0, 12. And it's a downward facing parabola. So it'll probably look, I could sketch it, something like that. Maybe. I didn't figure out where the vertex was. Yeah, somewhere like that. Okay. So anyway, it's just asking us for one answer. Oh, and it was only 1. I don't know why I was thinking 2. I was thinking of x-intercepts. Okay, so that would be this right here. All right, and they went ahead and put in 0 before expanding it, which is fine. I guess it might even be easier sometimes. I don't know why I didn't think to do that. But you could say 0 minus 4 times 0 minus 3 equals y, and then negative 4 times negative 3 equals 12. So when x equals 0, y equals 12. That's obviously acceptable, whichever way your brain likes to do it. But for these questions, I do think there are some questions that ask for x-intercepts. And if it asks for an x-intercept, then you would go ahead and set both of these linear portions equal to 0, and then solve for x. So if this question was asking for x-intercepts, I'll do that up here. If this was asking for x-intercepts, we'd be looking for where y equals 0. So I would set it equal to 0. And remember the law of the product of zeros, right? So if the product is 0, then one must be, or both must be 0. So either this equals 0 or this equals 0. So then I could add 4 to both sides and see x equals 4. And add 3 to both sides and get negative x equals 3, or x equals negative 3. So my solutions here for my x-intercepts would be 4, 0, and negative 3, 0. Right, the y value on my x-intercepts must be 0, because the x-intercept means we're crossing the x-axis, and that has a y value of 0. Okay. Okay. So that's that first question. All right, factor to standard form. Rewrite the quadratic function below in standard form. And I showed you this a second ago. Standard form just looks something like this. Okay. I don't think you had to say that. Okay, rewrite the quadratic function below in standard form. So we have negative 2x plus 4 times x minus 2. So we want it to look like something like this, and right now it looks nothing like that. So we're going to multiply our binomials. X times x is x squared. X times 2 times negative 2 is negative 2x. 4 times x is 4x, and 4 times negative 2 is negative 8. Then I just combine my like terms. Negative 2x plus 4x is positive 2x. And then I multiply the negative 2 in, so I get negative 2x squared minus 4x plus 16. And that's it. We want to make sure that the x squared term is first, and the linear x is next, and then the constant term is last. Negative 2x squared minus 4x plus 16. Okay. And they did the same thing we did. All right, so vertex to standard form is very similar to that. We're just simplifying to get it into standard form. So we have negative 2 times x plus 4 squared plus 4. So this is negative 2 times x plus 4 squared. I will expand that to x plus 4 times x plus 4. And then we multiply, distribute for our binomials here. So that's x squared. X times x is x squared. X times 4 is 4x. X times 4 or 4 times x is 4x. 4 times 4 is 16. I still have this plus 4. So negative 2 times x squared plus 4x combined like terms is 8x. Then I have to put my negative 2 inside, so negative 2x squared. Negative 2 times 8x is negative 16x. Negative 2 times 16 is negative 32, and I still have this plus 4. Remember, this plus 4 is not being multiplied by negative 2. And then finally combine my only other like terms right here. Negative 2x squared minus 16x. Negative 32 plus 4 is negative 28. Okay. Negative 2x squared. I'm typing this in, keeping the work shown so you can look at it. All right. And there we go. I did the same thing. Expanded this. Distributed, combine like terms, distribute again, combine like terms. Okay. All right, so graphing parabolas, level 1, they want you to graph, I believe, 5 points, and it says including the roots and the vertex. Now, the roots are where it crosses the x-axis, and the vertex is the max or min point of the parabola. So for instance, say I have a parabola that looks like this. This would be my vertex, and these would be my roots. Now, how do we find the roots of the function it gives us? Same way we always find the roots. So we set this thing equal to 0. Because what we're looking for is the x-intercept, and an x-intercept is where y equals 0. All right, so then we can solve this by factoring, or I mean, this might even be like a guess and check kind of thing just because it's really simple numbers. But I'm going to factor. The only two things that multiply together to get negative x squared are negative x and x. The two numbers that multiply together to get 8, or to multiply together to get negative 8, I should say, are negative 4 and positive 2, or negative 2 and positive 4. So I'm going to, maybe you don't remember our lesson on factoring. We want two numbers that multiply to get AC and add to get B. I don't know why I chose caps here and lowercase there. All right, and what is AC? In this situation, it's negative 8. And what is B? In this situation, it's 2. Okay, what two numbers multiply together to get negative 8? Well, negative 4 times 2 is negative 8, but negative 4 plus 2 is negative 2. And we want B to be positive. So the only other two numbers that multiply that'll work are positive 4 and negative 2 equals negative 8. And 4 minus 2 equals 2, which works. So I'm going to put these up in here. So we have positive 4 and negative 2. And we could check our work here. This would be negative x squared plus 2x plus 4x minus 8. Oopsies, what did I do? That didn't work. I go backwards. Minus 4 plus 2, negative 2 minus 4. Oh. 2x squared minus 4. Negative 2 plus 4. Okay, there it is. All right. Yeah, there we go. That worked. Okay, so we have positive 4 and the negative 2. The negative 2 that we chose as a term comes from these two being multiplied together. We didn't deal with a lot of these in class, but that negative there, we just got to be careful. So I just checked my work, but negative x squared, see if we multiply these together, we negative x squared. These two give us negative 2x. These two give us plus 4x, and that gives us positive 8. So now we can see these would add together to get positive 2x. Okay, the reason why we factored, if you don't remember, because that took a second, the reason why we factored is that we can separate these and set them both equal to 0. And when we do that, we get negative x equals negative 4, so positive x equals positive 4. And we get x equals negative 2. So these are my roots. So these are 2 points that I know. I remember these are roots, so they're the points 4, 0 and negative 2, 0. These are my roots. So these are points right here, negative 2, 0 and 4, 0. Oops. There we go. Now I need the vertex. The vertex comes from this guy right here. And has a lot to do with the completing square thing, kind of. We take the B term, take the B, vertex, take B, divide it by 2 times A, negative B, and we take the opposite sign. So B is 2, so negative 2 over 2 times A is negative 1. So negative 2 over negative 2 gives me positive 1. So so our vertex is at the point x equals 1. Now the problem is x equals 1 is here, and that could be any of these points. We don't know, right? So we need to figure out what the y part of that coordinate is. So far we know 1. What is y when x equals 1? Well, we just go back and we plug in 1. So negative 1 squared plus 2 times 1 plus 8. Notice I didn't do negative 1 squared because this negative is like on the outside here. So that's negative 1 plus 2 plus 8. Negative 1 plus 2 is positive 1. 1 plus 8 is 9. So this is the point 1, 9. And that's right here. Okay. And then it just wants us to find 2 other points. So I'm going to pick something easy, like what is y when x equals 0? So if you want, we could make like a little table here. So we found the roots, 4, 0, negative 2, 0. We found the vertex, that's 1, 9. Let's pick another x that would be easy to figure out, like 0. If I plug in 0, what is y? So that's 0 plus 0, because I'm just plugging in 0 for x here. These terms just disappear, plus 8. So when x is 0, y is 8. So let's go over here. When x is 0, y is 8. That's our y-intercept. All right. And because this is a parabola that this one just happens to be symmetrical, I know that this point has to exist as well. This is the point 3, 8, and we could check that. You could check that work. So that's negative 3 squared plus 2 times 3 plus 8. That's negative 9 plus 6 plus 8. Negative 9 plus 6 is negative 3. Negative 3 plus 8 is 5. Did I do that right? Negative 9. That's the point 3, 5. 3, 5. There we go. Oh, I see. This is the symmetrical point there. Oops, I would have gone too far. Okay, good thing I checked that. All right, anyway, this would have been the correct point right there. So let's take that one away. And that's the symmetrical point I was talking about. I'm glad I checked our work. And then so that's the point 2, 8. Okay, but it only wants you to do 5 points. But we can see that the point 3, 5 is also on there, right there. All right, submit. And so what they did is they just plugged in a lot of x values, which looks like a lot of work. I think even though we had a factor and everything, because I went through step by step like that, it might not be this much work when you do it. Just remember that when it asks you to find the roots, you need to factor and set the whole thing equal to 0. And remember, when you find the vertex, you do negative b over 2a, and that gives you the x value of that coordinate. Okay. All right. Now I think we're finally at our completing the square question. Oh, no, this one. Oh, these are easy for you, I bet. Solve the following quadratic for all values of x in simplest form. So we have negative 3 times x minus 6 squared minus 18 equals 9. It wants you to solve with square roots, which means we're just going to wind up taking the square root of both sides. So to do this, I'm going to add 18 to both sides. I did that step first instead of like dealing with this stuff because what I'm going to wind up wanting is x minus 6 squared on this side. That's what I'm going to end up with. And I could divide by 3 first, but it only works for this because all these numbers are divisible by 3. If this so happened to be like a 16, then that would just give me fractions, and that would make this really nasty. So I'm going to add 18 to both sides to kind of move it away from what I want to solve for. All right, and when I do that, we get 3 times x minus 6 squared equals 9 plus 18, which is 27. And now I can divide by 3 on both sides. And I get x minus 6 squared equals 27 divided by 3, which is 9. And now I can do what I said I wanted to do and take the square root of both sides so that I get x minus 6, because this is a perfect square, right? X minus 6 squared, the square root of this is the term that's squared. X minus 6 equals the square root of 9, which is positive or negative 3. And then just add 6 to both sides. So x minus 6 equals positive 3, and x minus 6 equals negative 3. Oh, yeah. Okay, so plus 6, making sure that this is the form that it wanted in. 3 plus 6 is 9, plus 6. Negative 3 plus 6 is positive 3. So our x values are 3 and 9. 3, 9. Okay, I guess that's the way I want it. Cool. Yep, and it did it the same way we did. Cool. All right, so this was just like a lot of algebra, but really we're just solving for x, and the easiest way to do it in the given form is to solve for this squared term and then wind up taking the square root. Okay. Okay, so complete the square, and this is what we talked about in the beginning of the video. All right, what is the intermediate step in the form x plus a squared equals b as a result of completing the square for the following equation? So I'll reference our original example. This was our original example. So the form that it's talking about is where we wind up having x plus 1 squared equals 16. That's the step it's talking about. So in this situation, I would have typed x plus 1 right here equals 16. So we're going to try to get that step. So here's our equation, x squared plus 35x plus 99 equals 15x plus 15. Okay, so remember we want constants on this side and things with variables on this side. So let's get rid of our constant that just so happens to be over here. So now we have x squared plus 35x equals 15x. 15 minus 99, I think, is negative 84. Yes. All right, and then I want to get rid of this thing. It's on the wrong side. It wants to be on this side with its x friends. So then I get x squared. 35 minus 15 is 20. Equals negative 84. Okay, so now I'm at that completing the square step where I take b, I divide it by 2, and then I square it. Okay, so b in this case is 20. So b over 2 squared. That's what I'm looking for. B is 10, or is 20, divided by 2, that's where I got the 10, squared. So 20 divided by 2 is 10, squared is 100. So that's what I'm adding to both sides. Remember, I have to add it to both or I'm completely changing this equation. So I get x squared plus 20x plus 100 equals 100 minus 84. I added 100 to both sides. Okay, I could have wrote this negative 84 plus 100, but I didn't have to. This is perfectly acceptable. It's still a positive 100. All right, now here is our perfect square, okay? And the way you're going to set it up is you're going to say x plus, and it's whatever this thing was. That's b over 2. That's what's going to go right here, b over 2, which was 10. Okay, this is x plus 10 times x plus 10. That's what this factors are expands out to. The number that you're going to put here is this b over 2 before it was squared. All right, equals, what is 100 minus 84? 16. Okay, so that's what it wants. It wants you to put x plus 10 on this side and 16 on this side. Submit. Done. And I think it did it the same way. It combined the like terms. And, oh, that's kind of silly. It did that extra step for no reason. And then we took b here and we divided it by 2, which was 10, and then we squared 10. And it looks like it just went ahead and factored this, but like I said, the number that goes here next to this x plus whatever is that b over 2 term. It's b divided by 2 before it was squared. Okay. All right, complete the square, rational only. That just means it has rational numbers. Rational number solutions, I mean. Okay. All right, here we go. X squared plus 15 equals 8x. All right, this does not quite look like what we normally deal with. I want to have x's on this side and constants on this side. So I'm going to, let's subtract 15 first. So I get x squared equals 8x minus 15. And then we'll move the 8x over so that I get x squared minus 8x equals negative 15. So now we have the same thing. It's just kind of set up different. All right, so now I need my b over 2. B is negative 8. See that? This thing right here next to the linear x term, the coefficient on that is negative 8. All right, so then I take b over 2 and I square it. B is negative 8 over 2, and I square it. Negative 8 divided by 2 is negative 4. Squared is 16. All right, so that's what I'm adding to both sides. To complete my square, I'm adding 16. Just like when we added that little square with an area of 1. All right, so then 16 on this side as well. All right, now remember this thing, in order to complete my little square, my perfect square here that I made, the thing I want to put here is that b over 2. It's b over 2 before I squared it, and that was negative 4. So this is x minus 4 squared equals 16 minus 15, which is 1. All right, now we're almost there. Now I'm just going to take the square root of both sides. The square root of this is x minus 4. The square root of this is positive or negative 1. All right, now I can split this up into x minus 4 equals 1 and x minus 4 equals negative 1. Add 4 to both sides. X equals 5. Add 4 to both sides. X equals 3. Done. 3 and 5. Okay. Let's see, it did everything the same way, I believe. Constant term on the right, b over 2 squared. Added it to both sides. Square rooted of both sides. Split them up. Okay. Last question. Complete the square with where a is greater than 1. Because so far we've only dealt with x squared where the coefficient was 1. All right, so we have 4x squared plus 56x equals negative 128. Now the first thing I would try if I was given something like this is, well, can I divide by 4? You know, does 4 go into this? And it does. 128 divided by 4 is 32. So we can factor this 4 out, or I can just divide by the 4 and then do everything completely normal. And that's exactly what I'm going to do. It'll give us the same solutions as if we just factored out the 4. So I'm just going to divide everything by 4. Okay, this is totally legal. 4x squared divided by 4 is just x squared. 56 divided by 4 is 14. And like I said before, 128 divided by 4 is 32. So negative 128 divided by 4 is negative 32. All right, and now we're pretty much in the same point we were last time. So I have to figure out what is my b over 2 squared. Well, b is 14 divided by 2 squared. So that would be 7 squared or 49. So we're going to add 49 to both sides. So I get x squared plus 14x plus 49 equals positive 49 minus 32. So then I get x plus 7 squared, right? This thing right here is my b over 2 before it was squared. X plus 7 squared equals 49 minus 32 is 17. So this will not give us a pretty number. All right, we're going to take the square root of both sides. And that gives us x plus 7 equals positive or negative 17. Oh, positive or negative square root of 17. Okay. Remember, 17 is not a perfect square. In fact, it's a prime number. So the square root of it is not some pretty number. And I'm going to leave it like that because this is the most accurate form of an answer. Plus, this gives us a little square root. So it's telling us to definitely do it that way. All right. And then I just subtract 7 onto both sides. So this gives me x equals negative 7 plus or minus the square root of 17. And that is our answer. And it's easy to put that in here because we have negative 7. And then we just hit this little plus or minus the square root of 17. There would have been no way to find that by factoring. You could use the quadratic formula if you think that's faster, but I think this is, not too bad, especially once you get in the hang of, where the b over 2 goes and the process of dividing by 2 and squaring. Obviously, you don't even have to write this part. If you just saw b was 14 divided by 2, 7 squared is 49. But those things come with time. You could have factored the 4 out first and left it like 4 times x squared plus 14x. And then equals 4 times negative 32 like this. And then eventually divided by 4 on both sides or whatever. But this is perfectly legal. It's fast. Maybe this isn't the best notation just to draw a big line and divide by 4, but it's the same thing. We could probably do it with better notation like this. But it means the same thing. We divided each term by 4. Okay, so that is it for the remote learning number 2 assignment. And this is the video is about the same length. But yeah, I hope you guys are having a great day and go out and enjoy the sun. Make sure you get some exercise. It's good for you. All right, bye. See you later.